Hello and welcome to yet another South Korean college Scholastic ability test video. Today we are going to solve the following problem. The cubic function y equals fx satisfies fa equals fb equals 0, and for its derivative f prime a equals f prime c equals 0 for three distinct real numbers a, b, and c. What is the value of c in terms of a and b? So basically, this is the problem to check whether the students have a solid understanding about the graphs of cubic functions. And let us actually think about these graphs. How many different types of graphs are there for cubic functions? Well, we can categorize the graphs of cubic functions into 6 different types using 2 characteristics from their equations. The first one is the leading coefficient. When it is positive, the graph eventually increases, when x becomes sufficiently large, and when it is negative, the graph eventually decreases. The second one is the characteristics of the derivative. The derivative is a quadratic function, so the equation f prime x equals 0 can either have 2 distinct real roots, a double root, or 2 imaginary roots. First, f prime x equals 0 having 2 distinct real roots means that there are 2 points where the slope becomes 0, hence the graph features the local maximum point and the local minimum point. When f prime x has a double root, then the slope becomes 0 only at a single point. Finally, for the cases of 2 imaginary roots, the slope never becomes 0, so the graph always increases or always decreases. In the problem, it is given that the derivative becomes 0 at 2 distinct points where x equals a and x equals c. This only leaves these 2 cases where the slope becomes 0 at 2 different points, the local maximum and local minimum. Next, let us combine this result with these conditions about the values of the function. Here, let us especially focus on the fact that fa equals 0 and f prime a equals 0. The derivative condition tells us that fx is either local maximum or local minimum at x equals a, and this condition tells us that fx becomes 0 at that specific local maximum or minimum point. Therefore, the possible candidates for the graph of fx are these 4. The derivative, which means slope, is 0 at x equals a and x equals c, and at x equals a, the value of the function also becomes 0. Moreover, due to this fb equals 0 condition, the other point where the graph meets with the x-axis must be x equals b. Now what does this tell us about the actual mathematical expression of fx, the equation of the graph? Here I will utilize one very important property of polynomial functions. I claim that if fa equals 0 and the derivative f prime a equals 0, then the function fx must contain a factor x minus a squared. In this case, fx is a cubic function and fb equals 0, so we can write fx equals some constant k times x minus a squared times x minus b. Now it is kinda obvious if you think about it, because if you want to find the derivative of a function in this form, you have to use the product rule, and fx must contain x minus a squared in order for its derivative to satisfy f prime a equals 0. So it is fairly obvious, but if you want a stricter verification, let me briefly prove this in a more formal manner. Here we can write the cubic function fx as the leading coefficient k times first x minus a because fa equals 0 and x minus b because fb equals 0. And we have a third root, but since we do not know whether it is a or not yet, let us denote that third root as gamma. And we are going to prove that this gamma must be equal to a. Here we will use the fact that the derivative f prime a equals 0. So if we differentiate this function, again using the following product rule, we obtain f prime x equals, first we differentiate x minus a, so we have k, x minus b, x minus gamma. Then we differentiate x minus b, so we have k, x minus a, x minus gamma, and then we differentiate x minus gamma, so we have k, x minus a, x minus b. Therefore, if we substitute x equals a, these parts become 0, and we only have this part, so we have k, a minus b, a minus gamma, which must be 0. In the problem, it is given that a is not equal to b, So this cannot be 0. So this a minus gamma must be 0. Therefore, we have gamma equals a, which means fx is expressed as k x minus a squared x minus b. Alright, now we found that fx is expressed like this. Let us express c in terms of a and b. Here, we will use the fact that f prime c equals 0. So we take derivative using the product rule. So first, 2k x minus a x minus b plus k x minus a squared. Here we have k x minus a as common. So let's write k x minus a. And the remaining part is from here, 2x minus b plus, and from here, we still have one more x minus a, which gives k x minus a times 3x minus a minus 2b. Since f prime c must be 0, k c minus a, 3c minus a minus 2b must be 0. And here a is not equal to c, so c minus a cannot be 0. So this 3c minus a minus 2b must be 0, which gives c equals a plus 2b over 3. So from our multiple choices, the correct choice is choice 4. Moreover, if you're familiar with the concept of internal section, you will notice that this result means that the ratio of the distances from C to points A and B along the x-axis is 2 to 1. And if you doubt, you can always calculate this ratio using this value of C to find out that the ratio is indeed 2 to 1. And I think that's all for today's video. Thank you all for watching, and don't forget to hit the like and subscribe buttons if you enjoyed this video, and I will see you in another video.